Mm. Oh, wonderful. And also, I mean, I feel like a talk like this ends up generating some questions, some conversation. Do you think it's reasonable, Danielle, if I aim to finish in roughly a half hour and just open it up for questions after that? Um,
Oh, yes, that will be fine.
okay. It'll be tough for me. I like talking and I have slides, but
Usually we do about 45 minutes of talking and then 15 minutes of questions. But feel free to handle it whichever way you
okay.
feel
All right.
necessary.
I'll try to finish up sooner because I mean, depending on the mix, like yeah, I might be covering things that's, better to point to it than to go into detail. So we'll see. Yeah. Ah, great. Yeah, I think it's wonderful that you all do this in the evening so those who have full-time jobs are able to participate, to hear.
Thank you. That's nice of you. And I want you to know that we have a YouTube channel too. So most of what we do goes onto our YouTube channel,
Oh, okay.
hopefully to live for a long time.
Ah, great. And it's been how many years? Because I saw a little bit on the web page, but how many years is this multiple literacies lab been going on?
So I started it a while ago, but then we decided to start the recording. So I'll say that we started recording and doing the webinars about 4 years ago.
Oh, okay. Oh, great.
And we just have one more minute left.
All right.
And I'm really happy to have Sarah, Trisha, and Katie um, as the co-directors as well, so that we can have these collaborative efforts and share research.
Okay, great.
Good evening, everyone, and thank you for joining us tonight for the presentation Supporting Artificial Intelligence, Managing Resources and Student Needs for Intelligent Systems. Our distinguished presenter tonight is Dr. Mark B. Albert, who happens to be the new chair of the Department of Information Science and the director of the Biomedical AI Lab. So, Dr. Albert's biomedical AI research team has worked with multiple hospital systems, bringing AI tools and approaches to clinical care. His focus is on reliable, efficient, and interpretable intelligent systems to improve clinical decision making, primarily applied to address patient mobility through wearable devices. So, without further delay, I bring to you Dr. Mark Albert. Thank you for joining us tonight.
All right. Thank you, Daniela. A wonderful introduction. So yeah, I'm glad to talk with everyone here today. Um, wonderful coming in as chair this September. And yeah, I mean, I'm just happy to speak with you about all of the related work that we'll be talking about today. So, um, first of all, I wanted to take a moment before we get into some of the details about the motivations, for this talk. And as I mentioned before earlier with a few of you here, I'm hoping to end in about a half hour, so we have plenty of time for questions because I think some of this will help elicit a few questions from all of us. Um, but again, the motivations here, I mean, this it was out in the flyer, but I wanted to highlight a few things. We're in an era where, we're talking about AI voice assistants that can, help radiologists to interpret chest X-rays. We had a wonderful presentation from Health Informatics, last week about this. Um, and there are similar tools that are being applied across all disciplines, all over the place. Um, there's a lot that's involved in creating, maintaining, validating, and storing, systems that are capable of this. Um, so libraries, have always had a role. I mean, early books and then digital. There's just and I think one of the critical things that carries over as AI becomes more prevalent is a lot of the core concepts that underlie that underlie the role of libraries over time. So accessibility, equitable access, vetting resources, for knowledge exploration. Um, these are all things that are going to become even more relevant as the capabilities of AI systems, in essence, concentrate power into, fewer and fewer hands. So I think that's something that's, again, very driving force, not just for this discussion here, also my movement into information science. And I hope a number of you also, hope to see more equity in some of the interesting and powerful tools that are coming out there. Um, but one of the more unique aspects that's coming into being is the fact that, it's not just physical books, it's not just digitized books, it's not just databases. I mean, now we have these systems that are neural networks that you can have conversations with. You have these systems that they can generate reports, they can do research, they can write research reviews, you can have Q&A. And how do we deal with managing that? Today's not about the details of that. I mean, a lot of the details, it's really a degree. Like, it's an effort to get there. But I think it's important to have this on the top of one's mind over time, as these capabilities develop, as they go from in the lab to in practice to something that needs to be managed and incorporated into the way that we navigate the knowledge that's out there. Um, so that's a lot of the motivation. Um, Introduction here. I'm just so first of all, Daniela, wonderful. Mentioning the bio. I'm going to throw out a few other things, and the reason I do this is the same thing that I do when I teach a class. I like to say where the background I come from. So if you have questions here that dovetail, related to that background, that's great. Also, if you want to ask those questions well after today, weeks, months, heck, even years, respectfully with time, but go ahead and ask those questions. And so, yeah, I some of the things that I might say actually tied to my experience. It was a degree in computational biology where I was studying computational neuroscience. We're going to talk about deep learning and then that's applied artificial neural networks. But there's a lot of analogy and a lot of insight into how we operate, how our brains, our neural networks that are in our heads operate. And I may throw out a few analogies there. Um, you know, I, I've the bulk of my research now is involved in um, medicine, in healthcare. A lot of it tied to wearable device analytics, trying to help clinicians address mobility impairments, and in particular, getting convenient, objective, and continuous data, in order to assess different physical and drug therapies. Um, I was in computer science before, but while I was in computer science, I also had a pretty long stint, about a decade, as an adjunct in physical medicine and rehabilitation in Northwestern. Um, a lot of AI background. I was the AI program director. I actually founded the MS in AI that's at UNT. Um, and there's going to be a coming cross-college AI institute that will be advertised relatively soon. That's going to start January 1st. So, and I'll be a co-director of that. So again, a lot of AI experience, some, comp neuro, applications in medicine. So there's a lot of things that I'd be happy to talk about now or even later. So glad to throw that out for everyone. The other thing I want to say is, and this is maybe I see a few a number of students here. I always like to plug the AI Summer Research Program. Dr. Shao and I have been running it for a decade now. And as you can see here, it grew from something a little smaller to something quite a bit larger. And so we get about 60 students involved. And so some of the things that I'm going to talk about are not just my personal experience of my lab projects, but it's helping to coordinate, as you can see here from this last summer, faculty, a large number of faculty and PhD student advisors that are involved in a large number of these projects. And so it's not just personal experience, it's also, day-to-day experience in engaging with some teams across the university. Okay, so I think it's helpful here to, give a context, give an understanding when we talk about AI. In fact, I think, some of those points that are mentioned later are, they fall into place once everyone has a better understanding of AI and the terminology, techniques, and tools. So, and here, instead of saying I think it more to the point, what is deep learning? And I want to basically, to me, and to many, that's the hot area in AI now. And I'll get to why that's the case and why that's important. First, I want to be very clear. As we talk about AI, there's one of the primary aspects of AI is machine learning, systems able to learn directly from data. Uh, I don't want to, we can talk about reinforcement learning later, but one of the things I want to emphasize is these two different aspects that typically fall under, AI applications. Supervised machine learning is a strategy we're trying to make a prediction and and all kinds of scenarios in which that's the case. You go into you have an ailment, you go to the doctor, you want the doctor to diagnose you. That's a classification. You want to you want to come up with an intervention that'll help. That's a prediction based on different interventions. So essentially, you're taking a scenario and you're trying to make a prediction from it and build a system that's capable of that. A lot of us have a pretty good sense when we talk about AI about a system that's supervised machine learning, where you're producing an output. You give an input and you say, give me an answer, give me a response. Um, One of the parts that I want to emphasize today is actually a much bigger deal nowadays, much more important. It's unsupervised machine learning. It's the part where you don't necessarily have a goal yet, but you have a massive data set that you just want to have the system essentially understand the statistical relationships and all the data so that very quickly you can leverage it for these interesting supervised machine learning problems. So there might be a terminology discussion of unsupervised and supervised learning that's going to come up. That's why I wanted to flash this on here. And afterwards, people can feel free to chat, ask questions about reinforcement learning because there's a lot of interesting things going on there. Um, so just to be clear for terminology, we say AI very loosely. Um, and when we talk about AI, we're talking about intelligent systems that and there's kind of a division of AI expert systems, which are essentially, long story short, think of them as complicated flowcharts that get to very interesting behavior. If-then statements, conditionals, flowcharts, and so on. That's not what we're talking about typically when we say AI. Usually we mean machine learning, so learning statistical methods, from data that's presented to help with statistical probabilistic inferences. Um, Now, if we just stopped with machine learning, we wouldn't be in the same place we are now. If we were just talking about machine learning without deep learning, it would be, 2012. It would be a time that we had interesting machine learning techniques, but not the power and the capabilities of things that we're aware of now. Um, the systems that are capable of looking at an image and telling you what's in the image, parsing it, describing it thoroughly. Systems that are capable of listening to our voices and being able to respond using natural language. I mean, all of that is powered by, um, I mean, it's classified as machine learning, but in particular, it's using multi-layer neural networks in order to achieve, those responses, that capability. And so when we talk about AI, I just want to be very clear, essentially what we're talking about when we're talking about the big changes are it's deep learning. And so I'm going to spend most of the time on trying to clarify that and how that comes into play based on the motivations I talked about before. But one thing I want to hit home really hard is, um, I mean, there is when we talk about machine learning or AI, 15 years ago, people would go, oh, well, machines will never be able to do that. Okay. Um, Once we've moved in this direction of deep learning, multi-layer neural networks, we ended up coming up with capabilities that are doing things that we thought weren't possible by machines before. And again, like everything from generating poetry to images to driving cars. Um, and it's not a coincidence that a multi-layer neural network is capable of doing that, in part because that's what we have in all of our heads right now. And in all the process of evolution, natural selection, adaptation, um, it's not a random coincidence that it happened twice, both in biology and in applied neural networks, that you have these multi-layer neural networks. So we'll learn a little bit about both how these artificial systems operate, but also, some insights into how we operate. And so, I draw the analogy here. Part of that computational neuroscience that I did back in the day, I actually did put electrodes in monkey brains in the visual cortex to understand neural responses in vision. Um, and so that's a whole thread that I'd love to chat with people about. But what you do see is that you have, as you go from early stages of vision in the brain, in the human brain, in the animal brain, you go from relatively simple, um, we could say codes that take that pixel input and give you responses, starting with things like light and dark patches, and then edges, and then curves, and then more complicated shapes, all the way to the point where you'll have cells in the temporal lobe that um, actually will respond to individuals. Um, there's a interesting article, quite old by now, where they had a Jennifer Aniston cell measured by someone who watched a lot of Friends. And so this person had epilepsy. They had electrodes implanted to localize um, the uh, epileptic focus. And in that process, they measured neurons that would respond when Jennifer Aniston was present in a picture, and even when the word Jennifer Aniston was present. So, I mean, long story short, we have a system that goes from fairly fine-grained details to extremely complex responses. Um, and the way in which it performs that, it would be difficult to describe in words, but we actually build systems that behave somewhat similarly, and you can draw analogies as you go up that hierarchy. Um, and to give well, to give you a visual example here, AlexNet. So one of the first multi-layer neural networks in order to achieve image recognition near human level. Uh, one of the first layers, if you actually look at the patterns of light and dark that it responds to, it looks like this. And, let's keep it simple with black and white right now. It looks, each pattern of bright and dark that different neurons respond to look like this, and it's not unlike what you actually see in monkeys and other animals. So long story short, again, the analogies aren't just um, they're not just broadly true, they're also true enough to where you can actually take the code from a macaque, swap it into the layer of an applied neural network, and you'll get, better recognition behavior. Okay. And in fact, I had a student where they did that as part of their dissertation, is they actually took uh, early layers of a network that had representations like this and actually showed that it improved training. So, I mean, again, that's a rough sense of deep learning. Again, just multi-layer neural networks. And so, that's what, that's the structure that houses some of the systems that are capable of conversing and interpreting audio and a number of other things that we will hope to get to. Now, big question is, how do people utilize, these systems? Um, so, I mean, one of the big advances, one of the big differences that these deep learning systems bring is that before, let's say you're trying to build a system that can identify cars from images. Okay. Um, Previously, you'd have to hire someone who would pull out features from those images. So cars tend to be certain colors. So you could have a system that sees how much red, how much green, how much blue is in the image. So that would be one feature. How many circles are there? Because cars tend to have circles or ovals representing wheels. Specularities, cars might have a shine on it because the sun will shine on it and there might be some chrome. And so you can come up with all these different features and try to write something that extracts that and gets a number for each one. And when you have that strip of numbers, then if you build everything right, you can try to infer from that strip of numbers, uh, is that a car or not in the image? No one feature, a presence of a circle, presence of specularity, presence of a color. No one feature will tell you for sure if a car is there or not, but taken together, you'll actually get a system that does a decent job. Not perfect, but does a decent job. The problem with that technique is that even for something as simple as identifying cars, you would need someone that's a computer vision person that has a sense of things you could extract from images. You might also need somebody that knows a little bit about cars, just so they can figure out which one of those features might be better or worse. Um, and maybe they need like PhD level knowledge in order to do this. And so, long story short, it's expensive. You got to put someone in the middle to extract all of that. And even then, it might not perform as well as you would hope. It's kind of traditional machine learning. But nowadays, what we do is we cut out the middle person. Okay. Um, we recognize that, well, we don't really need to identify the circles. We don't really need to separate the colors, by hand. We can actually have the system perform that learning, go from, pixels to something more complicated like bars or lines, to something more complicated like curves, to something more complicated like conjunctions. But we can have the system just learn that directly as opposed to coding it by hand. And the advantage there is if you have enough data, you don't need the middle person anymore. Okay. And that again, that's a revolution, right? I mean, that's because then you need less expertise. In fact, you might not need an expert in that area anymore in order to build a system that learns as long as you have enough data. Um, the caveat to this, though, because it sounds wonderful, right? Oh, okay, we don't need the expert in order to build a system that can learn, that can solve our problem for us. It needs massive data, massive amounts of data, because you're learning from scratch. You're not learning from, some interesting tidbits that are helpful for you, but not perfect. You're learning from pixels where an individual pixel won't really tell you, everything you want to know. And so again, it requires a massive amount of data. But this does put into context, kind of two things to mention here. Um, what deep learning has done is it's moved us into a scenario where essentially the more data you have, the more samples you have, the more robust automated learning you can do. That's why deep learning is part of the big data craze. Um, a key aspect of this is with more data, more samples, you don't have to be as picky as to which features you're using in your learning. The system itself will, throw away features, combine them, figure out which ones are good, and build appropriately. Um, Yeah, because more samples means more robust automated learning. It's actually why massive data sets are helpful in really complex problems, because people can't possibly handpick the right features in all of these scenarios. And so, again, think about autonomous cars driving. To recognize a person from a bag, from a tree, from a sign, which is neither one of those, but might be a depiction of them. How to separate that on the fly in milliseconds, it's quite a challenge. Speech recognition, similarly, there are so many different, accents, so many different ways of saying something. And face recognition, we think face recognition is easy, but objectively, from a computer vision point of view, it's actually pretty hard. We've just been essentially evolved over time to be able to parse faces, easier. So, um, and a key aspect of deep learning to recognize is that as you have smaller amounts of data, old school machine learning techniques are probably a better thing to try, in part because they're often easier to interpret and they don't need as much data. Okay. But as you get to these really challenging problems like computer vision, speech recognition, face recognition, and a lot of things with that level of complexity, um, you essentially as the complexity of the problem grows, you'll need more data. And as more data is available, deep learning strategies start to be what's necessary. And again, like that's why you can talk to your phone. That's why the phone can talk back, with flexible natural language, is because of this capability. Um, I won't go into the standard deep learning process. I actually pulled this from a class I taught. Um, Other than to say you might not be surprised, like the steps it takes in order to build these systems or in order to train them. I highlighted a few things. You have to establish a clear metric of what success is, and very clear because the system is going to optimize this numerically. Collect relevant data. Something that gets skipped, and we might talk about this a little bit more later, is try not to train it from scratch. Try to find a system that's pre-built that you can leverage. Um, and then the rest is again like actually not too much unlike when you're trying to teach a toddler, teach a kid, sometimes a young adults like observe the errors, test them on something that they haven't seen before. I mean, there's a lot of analogies to the way we would train up a person, when it comes to the high level efforts for these deep learning models. Um, so I think, yeah, I think we're doing good on time here. I want to talk about what's here, what's now, and what's coming. Okay, in terms of deep learning of AI, um, because I feel like a lot of what we're discussing, if we're trying to, prepare literacies for AI, I mean, it's going to take years in order to build the systems to do this. We don't want to just do this for what we are aware of now. We want to try to do it for what might be coming over the years. Um, and so, what's here, what's coming? I have a list of some wonderful things that I might sit on at the end of the talk and just chat through those if I don't have any questions. Um, I'm just going to pick one particular case just for sake of time today, and that is transfer learning. And I think that gets at one of the interesting insights and capabilities of these deep learning systems that people didn't anticipate, prior to their creation. And so, let me be clear of the context here. There was a McKinsey Global Institute study trying to look at likelihood of techniques to be used in AI applications and the complexity. And basically, transfer learning at the time was tops. Okay. Um, you know, and by the way, there's a dashed box here. Transfer learning is tops. These techniques, well, transfer learning is a technique related to deep learning neural networks, as I just mentioned before. And I also dotted line circled dimensionality reduction related to unsupervised learning. These are all, pretty key strategies. And but let's focus on transfer learning for a moment here. Um, what do we mean by transfer learning? I mean, it sounds like if you're not aware, it sounds like the Matrix, right? Like, oh, okay, load me up. I want to learn Kung Fu. Boom, done. Um, it's not that, but it's actually not also too far from that. And let me explain why. Um, uh, in transfer learning, essentially what you're doing is that you are taking a neural network that was trained on a related problem, and you're taking parts of it and reusing it in a new neural network to solve your other problem. And so a classic case of this would be if you want to build a computer vision system to recognize planes versus trains. Okay, you could actually take a system that recognizes dogs versus cats. And you can take probably a good 80 to 90% of that network and just lift it, copy it completely from one, network to another. And you'll learn very quickly from that new network that you built, if you, whatever distinction is that, it actually turns out that dogs versus cats and trains versus planes, um, most of the architecture for that is shared. And so there's a lot of interesting insights you see when you see more transfer learning, that problems that might seem distinct because at a high level they seem distinct are actually not as distinct as we might think because there's a lot of similarities at the lower level. Um, and again, because the concept with transfer learning is in traditional machine learning, you'd have a task you're trying to learn, identifying dogs versus cats, trains versus planes, the make and model of a car, whatever it is, you'd train things from scratch. Of course, with transfer learning, it's as I mentioned before, you build a system that learns in one case and you use that network and carry it over to another case and just tune it a little bit. What are the advantages of doing this? Well, first of all, much faster training. I mean, if you're training from scratch, you're going to take so many cases that sometimes it's not even practical. You can't even do that for a problem. So it speeds up training significantly. And the other part is it actually improves generalization. You need less data. I mean, I think that's probably the key is you need much less data. Um, I mean, before transfer learning, before deep learning, a lot of people had this feeling like, okay, the ability to generalize from one problem to another, dogs versus cats to trains and planes, that's a uniquely human trait, and it's not anymore. Like you can actually take pieces of a network, carry it over, and just with a little tweaking, use that network on a new problem, and the system learns way faster. Um, and again, I mean, the applications are endless. Um, matching some of the same applications of deep learning that I mentioned before. In fact, I would say transfer learning for complex learning problems is the norm now in a lot of applications. You start with what's referred to as a foundation model, where somebody like Meta or Google trained a massive neural network from scratch on all of the internet's text or millions of images or lots and lots of speech that was recorded. Um, And then you have a network that's you can that under has an understanding of the underlying structure of vision, natural language, or speech. And then it can be that network can be leveraged for problems, and you don't have to train it from scratch anymore. Um, And so, yeah, I mean, that's actually the norm in many cases, as opposed to, something new. Now that you have these pre-trained networks that took a lot of resources to pre-train, but to actually tune them to your problem, in my lab, and it's sometimes done by students with a laptop. Okay, so it's again a wonderful place that we're in. Um, and again, like to give you examples, I mean, you can go online and there are systems that you give them one picture of a flower and you say, tell me whenever you see that flower. That's transfer learning at play. The network to recognize any image, most of it's already been built, training on a lot of other image classification tasks. And then you just provide this one picture of a flower because a system that's been pre-built on other problems doesn't take a lot of data for its learning. Um, I mean, I'm listing a number of different strategies that I'll probably get back to if people aren't peppering with questions for the whole hour. Um, but I will, like I said, I actually have a copy of this at the end, and just because we could talk for hours on each one of these. Um, uh, how can we help our students? Um, I think I'm going to have just 3 slides here. So, like I said, I want to give plenty of time for questions and discussion. Um, yeah, and 3 slides here, but I think one of the most important things to recognize as we talk about, well, how do we make sure, people are prepared for this? What do we do with all of this, all of these advances coming? I think it's important to recognize that AI is not about a system that's going to take over our decisions and our responsibilities and it's going to do things autonomously. Yes, there's a couple cases of that. But I really think it's important to frame it as AI is about the people that are going to be using the machines. Okay. And the people that are going to be utilizing them. And I think we've all probably heard variations of this, but our jobs are not going to be taken by machines that make the decisions for us. They're going to be taken by people who use the machines that help them to be more efficient and effective. And I've seen that in the medical domain all over the place. And I think we just need to be prepared that across the board in a number of domains. Um, I'm going to go over these quickly, in part because I'll admit I had some inspiration from Gemini in order to do this. But just to give examples, hands-on experience and tool access. We have maker spaces that are becoming more prevalent, in libraries, and I think that something similar that's focusing on AI, possibly AI credits, access for people for some of the more interesting, challenging, applications of AI. There are robotics kits, but also, you know, some of the more interesting reasoning that's going on actually requires systems that are a little bit more capable of I'll say complex computations. It doesn't mean you have to understand what's going on under the hood. It just means literally you just need access to either API tokens, dollars that you can send to that you can input in the system to see what it generates, how it can generate under different constraints, and how that can be useful to you. Um, or you need the physical system itself that's capable of running a computation because some of these really interesting LLMs that are capable of interacting with your content and helping you summarize and helping you find what you're looking for can be run locally if you have the right devices. Um, of course, what's becoming more prevalent in discussion is also data and data access. Um, there's access to public data, but there's also making people more aware of the data curation that's necessary to power some of these techniques and these strategies. Um, and I mean, I won't go into vector database access other than to say, I mean, there are a lot of interesting systems now that are actually capable of reaching out for the data in order to feed to an LLM in order to provide the information that one's looking for. So it's not just coming straight from the LLM's memory, it's actually facilitated by pulling that, ground truth information and feeding that directly in before you ask the question. Um, Engagement and social impact. I think that, and this is not just personal, I mean, I'm sure there's data to back this up, but a lot of the people, a lot of the systems, a lot of the companies that are building these resources aren't thinking as hard about ethics as maybe they should. We'll put it that way. And so, building collections where, um, I mean, kids, like, all the way from, grade school all the way up are thinking about societal impact or, different aspects of policy surrounding AI. What could be done when there's job market displacement or how you would govern algorithms. It's hard to even think how do you govern algorithms without that sort of base knowledge that people might get when they're thinking about it deeply as they're growing up. Um, Film series and discussion groups goes without saying, and also forums where if there's AI in the news, a chance to chat about it. Um, AI literacy boot camps. I mean, that's one of the reasons why Dr. Shao and I run the summer program every summer. We like to, I mean, that's not a boot camp. I mean, that's 10 weeks and it's pretty involved. Projects, publication later, and so on. But everything from that to something a little smaller always helps. Um, and it doesn't have to be just generally broad AI all the time. I think people can really get tired of AI all over the place. And I'm apologies that I say AI a lot here. Um, but I think that's one thing that helps to tackle that is actually talking about discipline specific, AI applications and focusing on that. So it's not just yet another AI. It's actually focused on the use case, the benefits, the techniques that are specific to, a discipline. And so, I mean, that's generally the things that I wanted to cover. I just wanted to, thank and broadly, uh, you know, I've had a wonderful time, working with my lab of students. Actually, one of them passed their dissertation defense this morning. So George Mihaila there. Um, and it's just been wonderful working on a team in order to spread wings in all these different applications that we have. And it's given me an opportunity to work across hospital systems, so all the ones listed here. And so I'm happy to chat about those applications, where it comes into play. Um, and like I said, I'm going to sit on this as things that I'd like to talk about. But I mean, in the meantime, I'd like to open up for questions and thank you all. So, ah, okay. So I see a question from Richard. Or actually, no, I'm going to start from the top here. Um, Could Notebook LM and gem creation be part of Makerspace too? Uh, yeah, I mean, what I now are a little hamstrung by AI credits. They use OpenAI. They use Claude, and sometimes it's for benchmarking something. Sometimes it's to try a different strategy or technique. Um, and they're limited. Like, I mean, sometimes setting up the credits in order to try some of the things we want to try. Um, but remember, like, the things that a student learning how to utilize these systems might want to do. I mean, yeah, there's a free tier that you can often try things, but there's a big difference between, hey, Gemini, generate me an answer to this question versus Gemini, uh, you know, can you please write me a review paper over, this particular topic? Now, I'm going to give a caveat here. There's an issue when it comes to trust. A lot of us might be thinking when I say something like write a review paper, you're thinking 2 or 3 years in the past where you'd get hallucinated references. Now, yeah, it's not going to be as good as an expert in the field, but I think that the systems that are using reasoning tokens that actually generate ideas and cut the ideas that aren't good as part of the process, I mean, those systems are actually generating review papers that are better than a first year PhD student in most cases. And so, you have to have context when, when you're talking about, the benefits of trying these more complicated systems that might be require more resources. And again, the key here is not just to um, it's not just to try it out and say, look, that's nice. I don't have to learn anything anymore. That's a horrible takeaway when someone, experiences this. What it really means is you have a system that has, expert level knowledge with holes, but you have a system dedicated to answering your questions and digging deeper if you choose to. Okay. Um, and I think it's important to, make that distinction clear and actually to get students to recognize that early and utilize these systems for that Q&A and that understanding instead of answer my question just so I can move on and play frisbee. Um, okay. And then Richard, are there good websites or channels to keep up with the latest AI news or trends that you can recommend? Hmm. Wow, I don't have a good general. I mean, I could throw out conferences, but I don't. Um, I mean, generally, yeah, I'd have to think about that. Um, well, one thing I'd recommend, I mean, there's different levels to this, to an answer to this. If one were interested in the underpinnings of how these things work and you're interested in coding or something like that, um, PyTorch and TensorFlow are the frameworks of deep learning, and the tutorials for those are, if you have any coding experience at all, you can walk through those tutorials, and they were PhD theses 15 years ago, and they're just free to use and play with right now. And I think it's a wonderful way to get into how it works at a relatively low level. At a broader scale, I mean, there's just a lot out there. Coursera courses. I think I would recommend something deeper than a quick read. And so that might be a Coursera course or set of courses or a certificate or a class. Because there are a lot of people out there that get a superficial understanding, and we're starting to get saturated with those people. And it's unfortunate because it actually cuts off um, more intelligent conversation and collaboration when everything's surface level. And so at least like digging deeper than just news articles here or there. And I think Coursera courses, sequences of courses, certificates, degree programs, um, I think that's important. Let's see. Okay. And I see when I see companies like OpenAI, Anthropic release new models frequently. Oh, it just jumped. Okay, hold on. Ah, when I see companies like OpenAI, Anthropic release new models frequently, how to add novelty to research as a student with limited computation resources. There is always this fear that a new LLM would release and that would make my work outdated. So it's interesting you say that. So, um, I inherited a few PhD students from Rodney Nielsen's lab, um, and the focus of that lab was natural language processing, and this was they all started prior to ChatGPT, and then there was a little bit of a fear or a concern. Oh no, ChatGPT basically did what I was planning to do for my dissertation. Um, I mean, the thing to keep in mind is, I mean, every advance, um, I mean, you're always, you know, it's no one, it's very few people are going to create the next ChatGPT. But the person who makes a system, you know, work a millisecond faster, that's very valuable. In fact, you'd be a millionaire if you get Google to work a millisecond faster on answering questions. But it's also also important to make sure that whatever systems are out there are actually being they're useful for the people who intend to use them. And so let me give you an example. I mean, actually, a pretty general case here. Um, my research lab, all those PhD students I listed, um, we work with clinicians, um, and clinicians have very little time. They're not going to learn all the tools and techniques of AI, but they have tons of data that's been collected, and they want systems that can make inferences from that to help them in their decision making. Um, uh, Chat GPTs. I mean, all these LLMs that are out there are solving some of these problems, but some of the problems actually require tailored solutions, or they require validation to particular data sets, or they require thorough discussion with the person who's going to be using it to make sure it's in the format and the way that they need in order to use it effectively. Um, I think that there's an awful lot of work that isn't solved by just the LLM that gives you an answer that sounds intelligent. I mean, that's another way to put it. Um, the other thing I would say in this regard is there's actually a whole lot of work going on where you're taking these huge foundation models that in theory can do everything, and then people recognize, hey, that model is unwieldy. I can't even, I can't put it on my, I have to put it on a server that's beefy in order for it to be useful. But really, I want something that can run on my machine at home, or I can run it on a laptop, or I can run it on my phone. Um, Different sizes for different cases. There's a lot of taking those complicated models, making it smaller, tuning it to your particular problem. For example, I work with the Shriners Hospital system. One of the projects we're involved in is trying to make estimates for functional independence measures, pain scores, and fall risk in electronic health records. And we start with a system that was just generally trained on text data. And then someone else, not us, tuned it on publicly available clinical notes. And then we took that model and then further tuned it on Shriners Hospital clinical notes, which have a different flavor than just your generic clinical notes that are available publicly. And so there, my students actually did that on a laptop. It's not some big beefy model. And um, I mean, we're working with Shriner's data. It's not like it's publicly available. So you still need people to latch on to the particular needs and problems of that hospital network. And so, long story short, there are a lot of places for someone to dig deep when you're really thinking about making sure it works for the people who need it, as opposed to just trying to create the next ChatGPT or the next big startup. Again, if you actually go to the people who need it, I think you often find that there are problems that are a mix between data wrangling and understanding the person's needs and satisfying those needs in a number of different ways, not just technical. Um, Okay. And Katie Klein mentioned the crash course on AI. That's cool. Um, okay. And Sarah Evans had another resource. It definitely just there's wonderful stuff out there in terms of getting a sense of all this. Um, what frameworks, so Jenny Liang, what framework standards are currently used to validate AI clinical tools, and who should ultimately be responsible for monitoring model drift and safety issues in clinical AI assistance? Um, I won't be able to give you, I mean, it's not like there's a particular, person, tool, or technique other than to say your standard strategies in which medical devices are regulated. And so, yeah, FDA is is the key regulatory agency for medical devices, and to pass FDA regulations requires so much that by the time you go through all of that, first of all, you've probably frozen your system for quite some time in order to make sure it goes through all of the checks and balances. Um, but at least you know that it's going to be safe and effective. Um, I mean, that's just one example. Um, Let's see. Who'd be responsible for monitoring model drift and safety issues? I mean, that's going to depend on how things function in the hospital system. That would be a great question. I think we're still planning on inviting Cole Hinton, the head for data engineering for the Shriners Hospital Network. He was going to be at the InfoForce event earlier, and I think we're going to be inviting him back. That's a good question for him. How did they check drift? Um, so save it for April. Um, okay. Okay, and I have Daniela's question here. It is important. It is important to provide access to STEM learning for youth early. How would you start off with teaching elementary and middle school students to develop AI systems, building and training neural networks? I'm interested in doing more than starting them off with building algorithms on paper, like in CodeMonkey. Ah, so so yeah, elementary and middle school. I'd have to think about elementary, but I guarantee you in middle school there are some of those TensorFlow and PyTorch tutorials where they're not going to understand every line of code, and someone who shows it to them doesn't have to understand every line of code. But to see the capabilities and to know that they can actually have some vague sense as to what's happening step by step, I think is very powerful. Um, and again, I want to be clear here. We're not talking about making everyone computer scientists. Like not a thing we need to be thinking about. But we're looking at having a vibe coding class in the department. The concept being that if you can describe it in natural language, the system can generate the code for you to do the thing you want to do. Um, and I think that, with tools like that, and students at the level of middle school, maybe upper, elementary school, seeing those things relatively early and the capabilities that you have, basically giving them that sense of power and knowing it's not just for someone else, it's also for them. I think that would be really important. And so I'm glad to see, Daniela, that you're moving, or you're interested in that direction. Um, and again, I want to be clear here. I don't think it's just about teaching them coding. I think it's also about, teaching them the capabilities. And, when we develop this vibe coding class, just seeing how you can, as long as you're explicit in natural language to some of these systems, and you understand some of the really broad conceptual underpinnings. You can do an awful lot without having a degree or something related to coding. Um, Okay, so Nathan is saying there's a lot of hand wringing regarding AI use in archives. When analyzing large 100+ years of government data sets, would it be appropriate and ethical to identify consistent trends and make inferences? I currently hand code the data with XML and Stata. Um, and so well, you say consistent trends and make inferences. The first PhD student of Dr. Shao and myself, um, Sahar Bepur, like one of her papers was actually analyzing trends in academic literature. Lots of interesting, papers and efforts on that. Um, yeah, I think that it's always key to look at what the inferences are. look for examples where you know or have a sense of what it should be and see how much that matches before trusting it. But yeah, a lot of wonderful tools out there for that. So Rima, and I see just 3 minutes here, so I'll see if I can get to a few more. Um, so Rima is saying, do you have any advice on how to build something practical and effective with limited computational resources? RAG especially seems to require a lot of compute, and I'm trying to find a good way to approach it. Yeah, RAG. So, I mean, there's RAG where you actually pull from the internet, and that can be pretty costly. But you can also utilize RAG on local databases. So if there's, a large database that you might be able to pull from, if you run it locally, the cost drops pretty dramatically. Also, uh, like I said, limited resources can be done where you're using a smaller distilled foundation model. And yeah, a smaller distilled foundation model that can fit on something like a laptop and you can tune it. And you don't have to always go to the largest GPT model. You can, I mean, there are systems that again can run readily on a laptop just to demonstrate principle before you try something more challenging. Um, okay. And I think let's see here. So, all right. So Gayatri. Um, Comparison to neural processes and your example of the brain's cellular interactions. Oh, beautiful. That's nice. Um, Share a bit more about your book on human and artificial intelligence, the themes, and a number of other things here. Um, so, and sorry, I won't have time to get into, all of what you mentioned, Gayatri. And actually, I didn't get to these topics here, so I'll just speak directly here. Um, so yeah, that book was. Um, I mean, that book, it was bridging human and artificial intelligence, and there were a number of themes within it. Uh, what I liked about it was we actually had 60 people organized, and the typical chapter was actually a faculty member, a graduate student, and an undergraduate. And I think that was a wonderful way to bring it together to where we actually had a large scale organization and peer review effort to make it happen. So there's the process that I think was just wonderful with that book. Um, but in terms of I mean, part of the themes of it were we did touch on how um, there's an understanding of how the brain processes information and noting the analogies in these neural networks. Some of it was actually just describing how your brain processes information, so people have that context. Okay. Um, because and we didn't really have a chance to get into it, but again, a lot of the challenges that animals and people have had are the same challenges that applied AI systems have. And we've overcome them with relatively bad hardware. A millisecond to go from one neuron to another, whereas it's a tiny fraction of a nanosecond, in a computer. Of course, you can't directly compare across, but it's yeah, I just I just see that analogy there. But yeah, I mean it's an interesting book. I think looking at a table of contents, without without paying for it and downloading it, you can at least see some of the topics, and that might be a good starting point for, well, some chats with Gemini or ChatGPT to get into some of those details. So I see we're past 8 o'clock, and so I, don't want to be keeping anyone, longer than I'm allowed. Um, so yeah, thank you everyone for, a wonderful evening. And yeah, Daniela, would I be able to get a copy of the chat log? Do you have access to that?
Yes, it'll automatically download to my computer. I wanted to thank you for being here this evening and thank everybody for coming to listen to Dr. Albert. That was a wonderful presentation. And there were lots of great things to think about. And yes, I will download the chat log and send it out to everyone who registered and send it to you too as well, Dr. Albert.
Okay,
Thank you
great. I'll
so
try to
much.
follow up. Okay. All right. Thank you. Thank you, everyone. Okay. Have a good night.
All right, good night, everyone.